Okay, so let's dig into this a bit. When we talk about AI, right, especially these agents that are supposed to actually do things, not, interact with the real world, they can't just be stuck processing text or like making up stories based on old data. They absolutely have to connect to what's outside. And by outside for a computer system, I mean, well, external data sources, think databases, files, live info feeds, and also external services and tools, things like sending an email, checking the weather, maybe searching the web, or getting info from a company's internal systems. Now, for ages, the standard way for systems to talk to each other, to ask for data or get something done, has been through APIs, application programming interfaces. You've definitely heard of them. They're like everywhere. But AI is moving super fast, and the specific needs of these large language models, LLMs, and the AI agents built on them, they're kind of different from your traditional apps. Which brings us to something pretty new. Our sources talk about this open standard protocol introduced late 2024. It's called the Model Context Protocol, or MCP. And apparently it's already making quite a splash, as they say. So our goal here in this deep dive is to really get a handle on this. We'll look at APIs, the way things were, define MCP, the new approach. We'll compare them, see what's similar, what's really different, and figure out what this new standard actually means for how AI gets plugged into the real world.
That's exactly right. This whole challenge, connecting AI to the outside world, it's maybe one of the biggest hurdles we face. Moving AI from just generating language to actually doing things, being capable. It's the bridge, really, between the model's internal knowledge and the ability to act or get real-time info.
Yeah.
Without that bridge, AI agents are kind of stuck, isolated. So understanding how we build that bridge and, importantly, how we standardize it, that's crucial.
Absolutely. So first things first, let's get grounded in the familiar, APIs. When we're talking about systems needing to interact, what exactly is an API doing for us?
Okay, so think of an API like a formal contract. It's an agreement between two different pieces of software. It lays out the rules, the specs, the protocols, basically how one system, the client, can ask for stuff from another system, the server. It's kind of like a menu at a restaurant, right? It tells you what dishes are available, how to order them, and what you'll get back. But crucially, it doesn't show you the chef cooking in the back. All the complexity is hidden. And the reason APIs became so huge, so ubiquitous, is they let developers use functionality from other systems without building it all themselves. Our source material uses a classic example, an e-commerce site. Instead of building a whole secure credit card payment system from scratch, which is incredibly complex, regulation, security, bank connections, they just use a payment gateways API. The API clearly defines, here's how you send us the payment details, and here's how we'll tell you if it worked or not. Simple as that from the website's perspective.
Gotcha. So it's that abstraction layer concept. The website, the client doesn't need the nitty-gritty details of how the payment processor works internally. It just needs to follow the rules of the API, send the right info, understand the yes-no answer. All the messy stuff is hidden behind that clean interface.
Precisely. And the typical way this works for most APIs is a request-response cycle. The client sends a request, formatted according to the API's rules. The server gets it, does the work, maybe fetches data, maybe performs an action, and then it sends back a response, usually in a structured way the client can easily understand. Now, there are different styles of APIs, but the one our source focuses on, and frankly the one that dominates the web, is REST, or RESTful APIs. REST stands for Representational State Transfer. It's basically the standard for web-based APIs. And it works over HTTP. That's the same protocol your web browser uses to fetch web pages. REST APIs interact with resources. Think of a resource as a specific thing, like a user account, a product, a document. And you interact using standard HTTP methods or verbs.
Like DET and POST, those kinds of things.
Exactly. The most common ones are GET for retrieving data, like getting details about a book. POST for creating something new, like placing an order, or maybe borrowing that book in a library system example. Then you have POOD for updating existing things, and DELETE for removing them. The source used a library example, right? So ACT request to, say, books 123 fetches info on book 123. A post to loans with user and book info might create a new loan record. Pretty straightforward. And this is important, the data that comes back in the response is very often in JSON format.
JSON, yeah.
JavaScript object notation. It's text, easy for humans to read, but also structured perfectly for machines to parse. Just key value pairs, lists. Really good for representing data, like book titles, authors, dates, whatever. Now, here's the direct link to AI and LLMs today, many of the big commercial LLMs. You access them through a REST API. You package up your prompt, maybe some settings, into a JSON object. You send it using POST. The LLM service processes it, and sends you back the generated text, again, wrapped in JSON. And beyond just accessing the models, AI agents, the ones designed to actually do tasks, they heavily rely on REST APIs too. They use them for everything. Searching the web via search engines API, maybe scheduling a meeting with a calendar API, or accessing internal company data through custom APIs. APIs are basically the existing plumbing of the digital world.
Absolutely. And they're incredibly powerful, no doubt. I mean, the modern internet runs on them. We build whole applications just by connecting different APIs together.
Yeah.
And this is where it gets interesting for AI. They weren't designed specifically for AI agents. That's the key friction point, right?
Exactly.
The fact that every API is unique, its own rules, its own endpoints, its own data formats, its own way of logging in. If you have an AI agent that needs to juggle like dozens of these different services, that uniqueness suddenly becomes a real headache. A major challenge.
Yeah, it doesn't scale well from the agent's perspective.
Which perfectly sets the stage for this new development we're looking at, MCP. If APIs are the established general purpose way, what is this model context protocol that showed up in late 2024, and how does it tackle these AI-specific problems?
Right, so MCP, the Model Context Protocol, it is defined as an open standard protocol. But its design goal is laser-focused, unlike general APIs. It's specifically about standardizing how applications give context to LLMs and how they enable those LLMs, especially inside AI agents, to use external tools. It's built really from the ground up, thinking about how an AI agent needs to interact. The source material gives this fantastic analogy comparing MCP to the USB-C port on your laptop.
Okay, I like analogies. How does that work?
Well, think about USB-C, right? You have that one single port on your laptop. But you can plug almost anything into it, your monitor, an external hard drive, a network cable adapter, even the power cord. They're all totally different devices doing different things, probably made by different companies. But they all connect using that same physical port, and they all communicate using the same underlying standard USB-C. The laptop knows how to talk to all of them through that one standard connection.
Ah, okay. I see it. The laptop is the central system, needing different external functions. And USB-C is the single standard way to connect and talk to all those diverse peripherals. So how does that map onto MCP and AI?
It maps really well. In the MCP world, you have the MCP host. That's like your laptop. It's where your AI application, your AI agent is actually running. Then running on that host, you have MCP clients. These are the bits of software that actually start the communication. They open up a session using the MCP protocol. The source mentions JSON RPC 2.0 specifically, which is just a standard way for programs to call functions on other programs over a network, using JSON for the messages. And this MCP session connects the client on the host to external MCP servers. These servers are the equivalent of your peripherals, the monitor, the hard drive. They represent the external systems, the data sources, the tools that the AI agent needs to use.
So it's still client-server, like APIs?
Yeah, still client-server. But the key is that protocol they're using to communicate is standardized by MCP. And what these MCP servers do, fundamentally, is expose capabilities. That's the term the source uses. Just like a monitor peripheral exposes display capability, or a hard drive exposes storage capability. An MCP server exposes the specific functions or data it can provide. The examples given were things like access to a database or capabilities related to a code repository like listing files, maybe committing code, or functions for an email server, send an email, list your inbox. These are the peripherals for the AI agent, and MCP defines the standard plug-in communication method.
That USB-C analogy really clicks. It makes the difference clear. With APIs, it felt like needing a unique cable and port for every single device. Very messy.
Yeah.
USB-C and now MCP by analogy says, nope, one standard port, one standard protocol, everything uses this. Much cleaner.
Much cleaner and much more scalable.
Okay, so let's zoom in on those capabilities that the MCP servers expose. What can an AI agent actually do or get through this standard connection? What are these primitives you mentioned?
Right, the primitives. So the course points out that MCP is really designed to meet two fundamental needs of LLM apps, especially agents, when they look outwards. First, getting context, accessing relevant external data. Second, enabling action, letting the AI use external tools to get things done. And MCP facilitates this by defining a standard way for these servers to advertise their capabilities and for the clients, the agents, to use them. These basic units of capability are the primitives. The source talks about three main types. First one, and maybe the most obvious for making agents do things, is tools. Think of a tool as a specific callable action or function, like pressing a button on a machine. The examples are good. A weather service could offer a get weather tool. A calendar service might have a create event tool, or maybe a list events tool. An online store might have a place order tool. Now, when an MCP server offers a tool, it provides more than just the name. It gives crucial metadata. It provides the tool's name, obviously. A clear description in plain language vital so the LLM can figure out when it should use that tool. And very importantly, a schema. A structured definition of the inputs the tool needs, like location date for that weather tool, and also the format of the output it will return, like temperature conditions, etc. So when the AI agent decides, based on its task, okay, I need to use the get weather tool, it uses the MCP client to send a standard MCP request to invoke that tool. It provides the inputs according to the schema it learned about, and the MCP server on the other end then runs the actual weather lookup function.
Okay, so tools are for actions. What else?
The second primitive is resources. These aren't actions. They're about data. Specifically, read-only data items or documents that the server can provide. The agent can request these on demand when it needs background info, context for its task. Examples from the source included things like retrieving the text content of a file, or getting the schema of a database, basically asking, what tables and columns do you have, so the AI knows how the data is structured, or maybe fetching the contents of a specific file in a code project. These provide the sort of static or semi-static information the AI might need.
Makes sense. Context is key for LLMs. And the third one?
The third primitive mentioned is prompts templates. These are basically predefined templates that the server can offer up. They can suggest how the AI should phrase certain prompts, maybe guide it towards interacting in a specific way, or ensure some consistency. The source does note, though, that maybe not all servers use these heavily right now. Many seem focused mainly on tools.
Tools and resources seem like the main workhorses then.
Yeah, they seem to cover the core needs of context and action pretty well. But the real kicker, the thing that makes MCP so powerful for AI agents, isn't just having these primitives. It's that the AI agent can ask an MCP server at runtime to find out exactly which primitives it offers, dynamically.
Whoa, okay, so the agent doesn't need a pre-built list of every possible tool it might ever encounter. It can just connect and say, hey, server, what can you do for me right now?
Exactly. That is a huge shift from the traditional API world, because the MCP standard requires servers to publish this machine-readable catalog of what they offer. You can ask for it using standard MCP calls, like tools list, resources list, prompts list. It's like plugging in that USB-C device. The laptop queries it, and the device says, I'm a monitor, I support these resolutions via this protocol, or I'm a hard drive, here's my capacity, you can read-write files like this.
Right, the system discovers the capabilities automatically.
Yes. The AI agent's client gets back this catalog from the MCP server. It can parse the list, see the names, the descriptions, the input-output schemas for all the available tools and resources, and then it can dynamically incorporate that knowledge into its planning. So if the admin of an MCP server adds a new tool tomorrow, say a summarized document tool, the next time an AI agent connects and asks this tools list, it will see that new tool, and potentially it can figure out how to use it right away based on the description and schema.
Without needing a developer to go in and update the agent's code?
Precisely. No redeployment needed just because a connected service added a feature. That dynamic discovery combined with the uniform machine-readable descriptions. That's a massive win for building flexible and adaptable AI.
Okay, that dynamic discovery feels like the major difference maker. Let's really crystallize the key differences. API approach versus this new MCP standard. What are the main things setting them apart for AI?
All right, let's break it down. The force highlights a couple of fundamental distinctions. First is the design philosophy. Purpose-built for AI versus general purpose. APIs, as we said, are broad. System-to-system communication for anything and everything. Mobile apps, enterprise systems, web services. They weren't created thinking specifically about how a language model reasons or how an AI agent might need to interact with tools. MCP, on the other hand, was designed explicitly for that scenario. It standardizes the patterns that are most useful for AI agents getting context, using tools. The source says it bakes in certain assumptions that are useful for AI. The whole design is aligned with that AI agent worldview.
So it's tailored.
Exactly. And flowing directly from that tailored design is what the source calls MCP's strongest advantage. Dynamic discovery, we just talked about it. The agent connects, asks, what can you do? Gets back that structured list of tools and resources. This allows the agent to adapt, on the fly, to new capabilities or data sources it encounters.
And let's contrast that one more time with APIs, just to be crystal clear, because this really seems to be the core problem MCP solves.
Right. With your typical REST API, there's no standard way for the client, the agent, to just ask the server about its functions. The developer building the agent has to go read the API documentation, which is usually, a website, maybe a PDF. They have to manually understand the endpoints, the parameters, the response formats, how to authenticate, all unique to that API.
So the knowledge is external, human readable, not machine discoverable.
Precisely. And if the API provider changes something, adds a function, renames a parameter, the agent's code, the client code, is broken or outdated, it needs a human developer to read the new documentation and manually update the agent's integration logic.
Okay, I can see how that would be a nightmare for an agent trying to interact with potentially hundreds of services.
Absolutely.
Yeah.
Imagine that AI agent trying to manage your digital life we mentioned earlier. With APIs, someone has to specifically code. Here's how to talk to Google Calendar's API. Here's Gmail's. Here's Spotify's. Here's Slack's. Here's the company's CRM. Each one is a separate custom job. If Google tweaks its Calendar API, the agent's calendar function might just stop working until a developer fixes it. MCP aims to fix that. The MCP calendar server, email server, Spotify server, CRM server, they all expose their tools, create events, send email, play song, get customer record using the same standardized discovery tools list, and invocation methods.
So the agent only needs to learn MCP, not 10 different API dialects.
Yep. Exactly. The agent's core logic knows how to speak MCP. It connects, asks what's available, gets the list, and sees, this server offers create event described like this. This one offers send email described like that.
Mm-hmm.
And it knows how to call any of them, because the way you call them is standardized by MCP. This means if a new MCP server for, say, project management software pops up, the agent might be able to start using its tools almost immediately after discovering them. No code changes needed for the agent itself.
Which brings us nicely to the second big difference you touched on, standardization of the interface.
Yes. With traditional APIs, even within the REST style, every provider implements their interface differently. The specific URL paths, how they name resources, the exact structure of JSON for requests and responses, the authentication method, it's all custom.
A free-for-all almost.
Pretty much. So connecting an agent to 10 different APIs means building 10 potentially very different software adapters. A lot of bespoke work. With MCP, the protocol is the standard interface. Every MCP server, no matter what service it fronts, speaks the same language. It responds to the same discovery calls, tool list, etc., and the same invocation calls in the exact same format. This leads to that build once, integrate many idea from the source. You teach your AI agent how to use MCP primitives once. Then it can talk to any MCP server and use whatever capabilities that server exposes because the communication pattern is identical.
Huge saving and development effort, I imagine.
Massive. It makes connecting AI to a diverse ecosystem of tools and data sources much, much simpler.
Okay, so MCP sounds pretty great for AI agents. Tailor-made, dynamic discovery, standard interface, clear advantages. But you hinted earlier, it doesn't necessarily replace APIs, does it? What's the actual relationship here? Are they fighting, or is it more complex?
Yeah, that's a really important nuance, and the source is quite clear on this. First, let's remember the similarities. Both use a client-server model. Both give you that abstraction layer, hiding the internal complexity. And both are ultimately about connecting systems together, letting developers compose bigger things from smaller pieces, wiring things up instead of reinventing wheels. But the real kicker, as the source puts it, the key insight, is when you look under the hood of many MCP servers. What are they actually doing to fulfill the requests? They're often using traditional APIs.
Wait, really? So MCP servers are calling APIs?
In many cases, yes. Think of the MCP server as acting like a smart translator or a wrapper. It sits in the middle. On one side, it speaks the standardized AI-friendly MCP protocol to the AI agent. On the other side, it talks to the actual backend service, which might only understand its own traditional unique API. So when the AI agent sends a standard MCP request like invoke create event tool, the details, the MCP server might not have a built-in calendar. Instead, it takes that MCP request, translates it into the specific format required by, say, Google Calendar's REST API, sends that request to Google Calendar, gets the response back from Google's API, and then translates that response back from Google's unique format into the standardized MCP response format before sending it back to the AI agent.
Okay, that makes perfect sense. The MCP server is like a universal adapter and presents this clean, standard MCP face to the AI. But does the messy translation work behind the scenes to talk to the old-style APIs?
Exactly that. The source used the example of an MCP GitHub server. The AI agent talks to it using standard MCP stuff like tools list, or maybe invoking a dual-called repository list. But the MCP GitHub server itself probably doesn't talk directly to GitHub's core systems. It likely translates that MCP repository list call in to the correct GitHub REST API request, which might be something like get users username repos. It sends that REST request to GitHub's real API, gets the JSON back from GitHub, and then repackages that GitHub-specific JSON into the standard MCP response structure for the agent.
Got it. So they're not enemies at all.
Not at all. The source is clear. MCP and APIs are layers in the modern AI stack. APIs are still fundamental. They're the existing infrastructure for almost all digital services. MCP provides a new layer on top of that foundation, a layer specifically designed to be more usable, more discoverable, more standardized for AI agents. But it often leverages those underlying APIs to get the actual work done.
It's making the existing API world more accessible to AI.
Precisely. It provides that AI-friendly interface, often using the APIs under the hood, and that's why we're seeing MCP servers pop up for all sorts of things, as the source mentions. For file systems, for popular services like Google Maps, Docker, Spotify, and increasingly for enterprise stuff too, databases, internal business apps. Developers can build an MCP wrapper around an existing system or its API, and suddenly that system's capabilities are available to any MCP-speaking AI agent in a nice standard way.
Wow. Okay. This has been a really insightful deep dive into some core tech here. We've covered APIs, the established workhorse, introduced MCP, the new AI-focused standard with its primitives like tools and resources. We've really hammered on the key differences, that dynamic discovery and standardization being huge for MCP. And crucially, we've clarified that MCP isn't replacing APIs, but often layering on top of them, acting as a smart adapter. But let's zoom out again. For you, our listener, why does all this technical detail about protocols and standards actually matter? Why should you care?
Well, it matters because these standards, particularly MCP, directly enable the kinds of AI agents people are envisioning agents that can actually help you in the real world. The difficulty of integrating with all those unique APIs, that's been a major blocker. It made building versatile, adaptable agents really hard and time-consuming. MCP aims to break down that barrier by standardizing the connection and allowing agents to discover capabilities dynamically. It makes it much, much easier to build agents that can. 1. Access diverse, real-time external information, not just relying on old training data, but getting current stock prices, news updates, database records. And 2, actually perform actions across different services on your behalf, scheduling meetings, sending emails, booking travel, managing files, interacting with your work software.
So it paves the way for agents that are less like chatbots and more like actual digital assistants.
Exactly. Agents that aren't confined to just conversation or content generation, but can actively participate in getting things done across your digital landscape.
And because of dynamic discovery, they could potentially get smarter and more capable over time, right? As new MCP services pop up, the agent might just learn to use them.
That's the promise. They become more adaptable, more useful, without needing constant manual upgrades for every single new integration point.
It really does feel like a foundational shift for building next-gen AI apps.
It is. It's infrastructure. It simplifies the hard part of connecting the AI's brain to the hands, the external tools and data. And by making that simpler, we're likely to see more powerful, more integrated AI experiences emerge. Agents that can genuinely help us manage complexity by smoothly bridging the gaps between the different digital tools we use every day. So to quickly summarize, APIs laid the groundwork for system integration. MCP builds on that, creating a standard, discoverable, AI-friendly way for agents to connect to external capabilities, often by smartly wrapping those very APIs. It's a crucial layer for building more powerful AI agents.
Which definitely leaves us with something powerful to think about. If AI agents can now much more easily discover and use capabilities from any service that speaks MCP, combining functions on the fly, what kinds of tasks? Maybe ones that seemed way too complex or fragmented before, could they start to handle seamlessly? How might the shift really change how we think about building and using applications that have AI at their core?